The current structure of the concerts schema does not allow practical use of a multiple table insert. What I'm going to do is I'm going to create 3 separate tables based on the ticket table. This is a fairly practical application because the ticket table is extremely large. Executing SQL statements on the ticket table as a whole is relatively slow. So it would make sense to physically split the ticket table into 3 tables. The ticket table actually has 3 venues represented in it: Arco Arena, Compaq Center, and Orpheum Theatre. So what I've done is I've simply split the data in the ticket table into 3 separate tables named for the venues, as you can see here from the diagram. This is the sort of thing you would do in a data warehouse environment or an environment where you can handle split tables. It's really a form of partitioning to allow for better performance by splitting rows into separate tables. This is not necessarily a general standard use for a multiple insert table statement, but it will be effective in demonstrating how it works. Let's go on to my example. So the first thing I want to do is I want to go and count the rows in the ticket table, just to see where we're at. Relative to the other tables, I have a large number of rows in the ticket table. I have almost 300,000 rows. I'm going to set my columns so that I can see what's going on once again. Now I'm just going to go and verify what I have in the ticket table by grouping it based on the name and the venue ID, which should be the same, and they should produce the same number of rows, regardless of whether I group by both the venue name and venue ID, or venue name or venue ID. And here we have it. We can see we have 245,000 rows for Compaq Center, over 13,000 for Arco Arena, and 17,000 for the Orpheum. Now, it won't necessarily change the efficiency of access for Compaq Center by splitting up the tables, but it will affect Arco Arena and Orpheum Theatre. Think about searching simply for the Arco Arena in the entire ticket table. We're only actually going to select 13,000 rows from almost 300,000. If we would have to search through 300,000 records for that small percentage, which is about 3%, it would be much faster to search through a table with just the Arco Arena venues on, with only 13,000 records on it. I'm going to create the tables as create table statements with explicit column and data type specifications. I could have created these tables as a selection from the ticket table with the row number equal to 0. That would give me the structure. I don't want to worry about the keys at this point. Using the create table as a select from the ticket table would give me the index structures. All I'm going to do is I'm just going to create these 3 tables as empty tables. So I now have 3 ticket tables, 3 new empty tables representing the 3 separate venues: Arco Arena, Compaq Center, and Orpheum Theatre. Now I'm going to go and use the multiple table insert statement to insert data from the ticket table and split it into my 3 venue ticket tables, namely Arco Arena, Compaq Center, and Orpheum Theatre. Note that I could use the first option. The names of the venues splitting the data will ensure that I do not insert the same rows into different tables. Since I don't need to use first, I won't bother, so I'll just use all. The chances are first would be faster. Like a case statement using break commands, you would exit the current execution of the insert statement for the current row when a when clause succeeds. So let's execute this multiple table insert statement. As we can see, we have inserted from the ticket table into these 3 separate tables 276,750 rows. That's the total number of rows in the ticket table. Now let's go and verify the integrity of that multiple table insert command. Once again, I'm going to run my group by statement, and I'm going to check the counts for each venue. You can see here the total numbers for each venue broken up giving totals for tickets from the ticket table, not my new tables. We could even get fancy and use a group by roll-up clause in order to show the subtotals from the ticket table. And here we have the subtotals for each venue ID. As we can see, the numbers are consistent, and we have the total number of rows, which is the same as the total number of rows for the whole ticket table. Now let's verify the result of our multiple table insert against the numbers we've calculated with the group by and the group by rollup by counting the actual records from the newly created and inserted into tables. And here we have those results. As we can see, we've selected count from each separate table based on venue names, given them headings specific to those venues, and we can see that the totals for instance, Orca Arena are the same as in the ticket table. Compaq Centre is the same as in the ticket table, and Orpheum Theatre is also the same as in the ticket table. These are the counts from the new tables. Therefore, we have verified that our multiple table insert statement functioned correctly. Here's a graphical representation of what we have actually just done. We took these records, here's a group by clause on the venue from the ticket table. We passed them through a multiple table insert and produced 3 tables, which we then counted all the data from to produce the same totals across the 3 separate tables as the group by clause breaking up on venue from the original ticket table.